I'm a little teapot, short and stout. Hello and welcome to the Prom 9. And today's episode will be based on multimeters. We will be comparing a few of my first multimeters with my Fluke 25 that will be used as a reference. And just for a bit of fun, we're throwing a bit of the 1905A Furby. Yeah, we gotta. So we'll be comparing the Fluke 25 with... We're not going to do it with my new meter. My very first multimeter, a Rapid Electronics 212 digital multimeter. Oh, it's digital, how fancy. Yes, the story goes for this is I ordered this along with a whole host of other bits through my school. I managed to get the school science technicians to actually order the stuff on my behalf, to where I would then give them the actual cash for it because I didn't own things like debit cards. This was also one of the things I got back then, a USB to serial converter. Such a useful device, these. You should all have at least one in your junk box. So handy. Multimeter, battery tester, and I think the rest was a load of electrical components like red flashing LEDs and whatnot. Because I didn't have a debit card, so I couldn't order it online myself. And the parents were a bit sort of... which is why when I was back at school, pretty much everything was scrap. But it was nice to have a multimeter. Then eventually, when that multimeter decided to go out of spec and start giving me false readings, I picked up the Precision Gold PG012. But as you can see, it lacks a current measurement, which is not very handy. So I then picked up a PG10B, which has a current measurement. Taking into note some of the stuff Dave Jones said about multimeters, which is why I spent a little extra and got these. These two units were at the time about 20 quid. They since cost more now because Maplin still sells them. This was at college I got these, so I've had these for over 4 years now. Both of them. They're quite nice long probes too. They've also got nice little rubber surrounds on them. So, let's not waste any time. Let's get busy. So here's a look at our super duper precision power supply. No, not power supply, multimeter. This thing we're going to use for measuring our power supply, which we recently repaired just a few days ago because we blew it up a few days beforehand. Might help if we turn the output on too. And it measures 19.9923 volts when the power supply is set to 20 volts, which flicks between 19.99. So yeah, I've calibrated the meter on the power supply with this multimeter, so it's pretty damn accurate what you see on the meter to this, although not perfect. But yeah, it's pretty much, yeah, pretty good. Now, to give it the Fluke reference. And what voltage does the Fluke say the power supply is? It says it's 19.97. So not quite as accurate, but considering it's measuring against basically a precision multimeter, pretty damn good. So that'll be our main reference, 19.97. And just for fun, the only handheld 4.5 digit multimeter I have sees it as 975. So once again, we've got pretty good accuracy on par with the Fluke 25. This is a recent acquisition multimeter. which is on Facebook if you're not on there. Link in the description if I remember. There's a teardown of it on there. Facebook exclusive, so go join my group and you get some exclusive content now and again. Unfortunately, due to their internal circuitry, I can't seem to measure the same source at the same time on voltage. One ends up reading 10 volts when it's receiving 20 volts. So yeah, that's the one we're using now. Annoying! So the PG10 reads it as 19.96. So that's quite reasonable. It's certainly not as good as a Fluke, but it's one least significant digit out. So we're not too worried there. That's pretty reasonable performance. The second unit, on the other hand, the older of the two, the PG012, is 19.91. A little bit off for my liking, but it's livable. It's, you know, 6 digits out, least significant digits out, so it's no major deal. If you're just looking for a general ballpark figure, you know, it's perfectly fine. But now we get on to the crown jewel of the multimeters. And now we're on to the real crown jewel of the multimeters I own. My first multimeter. Which not only are the probes shorter, but it has no tilting bail. Grr. And, well, it overranges on the 20 volt range when all other meters have shown it's actually lower than 20 volts. So it actually reads high. I suppose it's better than it reading low and you're blowing up your circuit, but still. So we go to the 200 volt range. And we connect our multimeter back up, and it's 20.1. Okay, so, you know, it's supposed to be 7, 8, 9, 10. 4 least significant digits out. Yeah, it's less than the other one, but yeah. And the ohms range, which is why I replaced it, has just gone completely out of whack on this thing. That's why I replaced it with the other two. So, enough measuring. Let's tear these things apart, and we'll start with this beauty. So yeah, this thing's pretty crusty. You can see where I've vandalised it over the years and whatnot. It's got all these useless HFE things which I never found a use for, and there's never found anything on the internet. There's its labelling, which is actually a lie. You'll find out who it's made by, and it's apparently Cat 2 rated. I'd be surprised if it meets any Cat ratings, as you shall see. It's got your standard volts, amps, ohms, diode, no continuity beeper, 10 amp range, although I wouldn't measure anything high current on this. I'll really stick to just like 555 timer circuit, and the useless HFE, which the other two also have. Completely bloody useless. But yeah, you can easily, because the milliamps is on that jack and not a separate jack, like combined with the 10 amps, you could easily blow the shit out this meter by accidentally arranging it past the amps range if you're measuring something a little more high power. Well done, designers. QC passed. My arse. And we pop the back off. Ouch it out. You can see I've replaced the battery because the battery life on it is not amazing. And we are presented with, yay, crappy black blob chips. These are in everything cheap and nasty. I despise these black blob chips. They're boring, they're horrible, and there's just nothing good to say about them. They're cheap and cheerful. We have a spring for they added shielding, I don't know why. And a load of some of these are precision resistors and stuff. Most of them are your sort of standard gold band 10% error. There's a little transistor there, little spring to contact it, 9-volt battery. No input protection whatsoever, if you can really call that. These fuses can explode if you overload them, as I discovered with this power supply when I blew it up. And I was picking out bits of glass out the carpet. Yay! Some horrible soldering job around that. And the clearance is, well, as expected, abysmal. Bearing in mind, 10 amps goes right past the comm up here, round. Comm goes round here, to this. Yay! Through here, yeah, pretty abysmal really. Not much else to say about it. Not much better up the front end either. Let's show you. As a fun note, the range switch has just bare copper contacts. Another thing I forgot to mention, instruction manual. Yeah, really? That's a lie. It's a spec sheet. Completely useless. The other side, there's really diddly squid on it, just spindly, horrible range things, more terrible isolation. Look at that. The fuse might as well just not be there. It's terrible. Battery, not much strain relief. There's a little bit, which is, I suppose it's okay. Yeah, what you expect. Not much else to say then. Well, I keep it because it's my first multimeter. There is no other reason to. This unit fares a little better. For example, it has better probes, which are apparently Cat 3 1000 volt rated. They could probably survive that. I don't have a 1000 volt generator to test it though, but they do have nice long thralls and whatnot, and you can certainly put them to good use elsewhere. They're not unreasonable. This PGO12, which seems to somehow have lost its accuracy quite significantly, even compared to my cheapy Wonderland one, which is quite depressing, because this is a bit better, apparently. Well, it's once again got one of these useless HFE things. Why the hell they didn't put a useful function in there, I don't know. It's got a capacitance range thing, which is quite useful if you're not pulling them out of circuit boards, and so the pins are too short to fit in there, so limited use of that, but at least somewhat useful. And a frequency range, which is completely useless because the frequency counter on it is completely inaccurate, and the instructions, if I knew where they were, once again like the other multimeter, are a complete pile of turd and don't tell you how to use it. It usually reads double the actual frequency, so yeah, once again completely useless. It's got a diode, it's actually got a continuity buzzer. Yay, it's apparently Cat 3 600 volts, but I'm sort of more skeptical. While it's a better build quality internally, there are certain things missing. It's got a nice rubber surround, which as you can see, I've chewed it. I am still a bugger for chewing things. To this day, I cannot not chew something. Pens, screwdriver ends, anything will pretty much go in my mouth. I'm like a sodding baby. So we pull out that. No, it's got a pretty nasty tilting bail, but it does the job, and it's just fallen out of its thing. Blech. And we have the wrong screw. Apparently this has a serial number. It's made in Taiwan. It's got usual sort of nonsense safety stuff if you're too stupid to do. If you're stupid enough to electrocute yourself while replacing the battery on one of these, you deserve to die. This screw is a bit of a bummer because it's a bit worn out and doesn't come out until you open it and lose it down the bloody back of the sofa or something. So this is a bit more awkward to get open. But it does come open. It's got a nice little shield here, which seems to be not quite floating. It's got another one of these springy things. Yay! So you can make music with it if you're that way inclined. And you'll see it's instantly better build quality. The build quality is orders of magnitude better than the last one. And look, the other screw fell out. And it's got the buzzer soldered in, so that's reduced to wear and tear and will eventually break off. The board's a pain to remove, but there's really nothing under it. there's nothing interesting to show you, just that's where the cap's soldered in. It only does voltage, but clearance is okay between the voltage here and there. It's pretty reasonable. You know, we've got a PTC device, we've got a little resistor network, we've got a protection diode here. There is at least some protection, and also you're not likely to blow yourself up on a voltage only meter pretty much, and a little bit of resistance and whatnot, and some frequency measurement. Runs off a watch crystal, so quite reasonable for what it does. The other one's a bit more concerning because, you know, that's where the current range would be. But if you notice, not a huge amount of clearance. In fact, we can measure exactly how much clearance that has between the two solder points. And that is 1 millimeter. Bearing in mind these meters apparently can handle up to 600 volts, and that's also going to be the 10 amp range. That ain't so good, but this one doesn't have the current, so we'll reserve that criticism to the one that does have the current. But yeah, standard 7.4 logic, little probably generic multimeter chip. Little 4-pin device there, which might be a little flash. Nothing amazing, pretty standard. You know, if you want a multimeter that's 20 quid, does the job. Just be careful if you're going to use it for measuring anything high power, because I don't believe the protection in this is particularly adequate. You know, there's no MOVs, nothing like that. Put to expense. The second room has a 10 amp range, which is fused. Wow. Still about the same price, slightly more because there was the whole government thing with the attach. It's got an apparent battery test mode, which is just tells you the voltage really, so it's not that much use as a sort of good or bad tester. You know, some batteries can have quite a reasonable voltage, but they can't supply any current. Got one of these again. Why these things are useless? They could have more useful functionality in its place, like, I don't know, an ESR meter. I mean, you have to identify the transistors beforehand, so it's not even any good as that. But yeah, standard arrangement, nothing really to see. Same sort of tilting bail. This one I haven't chewed as much because I didn't use it as much. And same sort of horrible self-tappy screws which disintegrate and wear out, as you saw in the last meter. Yay! We like crappy screws. And the whole back of the case has to come off because, yeah, that's cheap. We got fast blow. These are actually not crappy glass fuses, and the shielding is no longer on the board, which actually makes it a lot more easier to work with. The speaker is still soldered in, no connector, no like spring contacts going up to make removing it, because that's going to wear out over time as you replace the battery. No strain relief on the battery, so pretty goddamn terrible there. And once again, now 1 mil clearance becomes a problem, or 1.34 mil. Yeah, that's what you have between your ground and your current range. It also uses pretty nasty jacks, but at least they're on this spacer board, which has a little bit of protection to hold it in place, so wear and tear isn't as bad. You've got HRC fuses, which are good, but once again it failed miserably on the clearance. Current shunt going straight across the ground. Look, once again, terrible clearance. At least you got the silk screen providing some insulation, but still, you know. And then that goes round to that goes through there, and then you get terrible clearance at this end. It's just, no, that's not how you do it. On the upside, there's a PTC device. Yay, no MOVs. We've got a diode array and a resistor array and a protection diode again. We've got our 10 amp shunt thing. We've got another type of IC up here. We don't have the watch crystal, so we'll use some kind of internal oscillator. We got a LM324 quad op amp there, you know, standard stuff. One thing that is nice, they supply it with a spare low amp fuse, which is 500 milliamps, 250 volts. So at least they're nice enough to give you a spare fuse for when you blow it up in an incompetent moment. Because it's very easy to blow these fuses. One moment of just pure lapse, wrong volt, current range or something. Yeah, annoying. But yeah, you also find the ground is also grounded up here, which is an interesting way of doing it. Although it's, yeah, it wouldn't take much for something to accidentally, a solder blob or something, to fly off into them. Bearing in mind you can open these up in your workshop, it's very likely that, you know, you could get crud in here accidentally without realising. Yeah, not so good. This has still got its original battery, I think. No mercury or cadmium added. That's good because that's good for the environment. Although if you're planning on drinking the contents of the battery, well, tough toodaloos to you. Once again, same sort of design. Traces. Pretty basic, really. I don't know if any of these are precision resistors or not. It's hard to tell. There's a lot of resistors though. But yeah, overall, okay. Okay, there's protection there, but the clearance is pretty poor. And well, where's the MOVs? You know, where's the systems to stop it re-arcing over again if it overloads? Yeah, once again, this is good for sort of battery-powered bench power supply use, but certainly not power use. You know, these meters are not like, say, this, which you could use to measure a bloody raw output of a nuclear reactor, and, you know, you'd be perfectly safe doing it, well, aside from the radiation. But something like this, nah. Stick to sort of hobbyist, low-current applications for these sorts of meters, and these are alright as first meters. I wouldn't use them for terribly long. Graduate to something like this, which gives you something better, and eventually find yourself some of these. I mean, yeah. Before we go, a quick note on these bench power meters. Be a bit careful about and I wouldn't recommend using them for high current applications because they generally don't have very good protection circuitry. So once again, low level, low current stuff only. Thanks.